In this video, for the first time, we're going to start to have the computer repeat a whole bunch of commands over and over again, sometimes called iteration. And the type of looping that we're going to look at today, probably the simplest of them all, is something called a for loop, where we literally count how many times we're going to go and do the commands over and over. As a flowchart, it would probably look something like this, and it's these statements here that are going to happen again and again and again and again. And we'll just count how many times we've done them. And when that counter hits a value that we're happy with, that's when we'll actually stop repeating those statements over and over. So off the start, we're going to have to do a little initialization. We're going to have to set up a variable, some sort of counter. We'll declare the variable and then initialize it at some original counting value, probably 1 for our first few programs. And then we're going to loop those statements over and over. And each time we loop them, the counter variable is going to have to be increased by 1. That way we can keep track of how many times we've done the loop, and when the counter hits the right amount, that's when we're going to stop. So for your little sample program, here are a few different loops that are hiding inside it. There's a few there, starting off with this very, very simple one that just actually does 5 loops, and each time it does the loop, it prints off which loop it's on. So you can see the output down below saying this is loop 1, this is loop 2, and so on. So a couple of things to notice about this. Actually, I'm going to start with these commands right down here at the bottom. These are new to you. System pause will actually give that little instruction down at the bottom saying press any key to continue, which can be kind of nice to just hold your program up until the user is ready to move on. And then system CLS will actually clear the screen, so when the program advances, the screen will wipe off and then you get a chance to do some fresh output. But the actual loop itself, here's the declaration of the counting variable that we're going to use. We have to have some variable that we're going to use to keep track of what loop we're on. So this one's just going to be called I, real simple variable name. And then the actual loop occurs in this section right here. The for command is actually where we're going to set up the loop, and then the cout is the stuff that's being looped. Let's just kind of zoom in on that particular section there just for a second. So within the loop itself, I've indented this cout command because it's special. It's going to happen many, many times. So it's just good programming practice to indent that, 4 spaces and say, all right, this thing's going to get looped over and over. And you can see that it's going to do that little display of this is loop number and then print off the loop number. Now the actual beginning of the loop is that line above it, the for line. So let's just dissect kind of what's going on inside the red brackets there. The first of 3 things is the initial counter value. So we've already declared the variable I. We've reserved that space in memory. And here's where we initialize it and say, well, why don't we start off calling the first loop loop number 1? Seems like a nice logical thing to do. The next part after the semicolon talks about the condition we're going to use to test to see whether we should keep looping. And so this one says I is less than 6. So as long as the counter hasn't reached 6, we're going to keep going. So we will do a 5th loop. We could just as easily have said I is less than or equal to 5, if that makes more sense to you. And so it'll go through the loop, and as long as we're not on the 6th loop, it'll keep actually doing it. And we do have to do this last part here where we actually increment the counter variable. That variable I has to keep track of which loop we're on, and it's this instruction here that takes the old loop counter value, adds 1 to it, and then restores it. That way we're continuously keeping track of what loop we're on. It is okay within the loop itself to access that letter or that variable I. So it is keeping track of which loop we're currently happening on, and you can display it if you want. There's nothing wrong with that at all. Be careful about doing a lot of math with it though. The last thing you'd want to do is start lowering the value for I within your loop, because then it may never get to 5 or 6, and your loop may actually just run forever if you're not careful. The next program is a little bit more interesting. This one is actually going to print off some perfect squares. In fact, that's kind of neat. This one does like 4,000 perfect squares, and the computer doesn't mind having to do these over and over and over. So a few things here. I've declared this variable SQ for the actual square amount that's going to get displayed at the end of each line, and then we go into the actual for loop itself. So taking a look at that for loop, there are a couple things that are different about this for loop. Just want to highlight them here. For starters, I didn't declare the variable I before the loop. It is okay to actually do it right as you first assign that initial value of 1. So we're declaring and initializing the variable all at once here. And that is okay, but you have to respect one thing. Because we've declared it at the for loop itself, as soon as the for loop is done, as soon as we get to that section in the program, then that variable goes what we call out of scope. You're not allowed to access it anymore. It basically disappears, and the computer can reassign that memory location to some other variable name. So you can do that if you like, that int I equals 1, but don't try to refer to that particular I after the loop. You won't be talking about the same memory location. The other thing that's different about this loop is in C++, if you want to, instead of writing I equals I plus 1, you can use this plus plus notation to increment that counter. And so it's kind of a cool way of actually just incrementing the variable I. There are some advantages to doing it this way, but for now I'm just offering that in there as an option. It certainly is kind of cool looking. The actual loop itself is here, and I had 3 lines that I wanted to loop, not just one, so I have to use a code block. By opening up those little curly brackets and then closing them, that tells the compiler, hey, the next 3 commands need to be looped over and over and over. And you can see what's going to happen here. It's going to print off this message. This is loop number whatever we're on, maybe loop 4, 5, 6. It calculates the square of that counter variable, and then here's where we actually go and display that value, which is actually right here, that SQ, right? That'll be the square of the loop number that we're on. And then at the end we do that same pause and CLS thing, which just kind of is nice, lets the user take a little break before we go and move on to the next part of the code. And speaking of the next part of the code, in that little sample program, the next 2 loops are actually a little multiplication table. They both try to make a multiplication table that's 6 wide and 3 deep. This first one doesn't have any like row or column headings at all, though. It just does the multiplication table. Right off the start, I'm declaring a variable called product. That's where we're going to actually calculate all those numbers that are in the table. And then we move into some loops. And this is neat because we're nesting one loop inside the other. The outer loop is actually the row loop. So you have to kind of look at it this way. 3 times we're going to do these row printouts, right? And then within each row we're going to print off the column numbers. But 3 times we do have to print off these interesting rows. So we'll start off calling the first row row number 1. We're going to keep doing this as long as the row number is less than or equal to 3. And we'll keep incrementing the row number as we go. And so that's the row loop. But then within the row loop is the column loop. So each time we're on a row, we're going to work our way across 6 columns. We're going to calculate what that current product would be in the multiplication table. I'm just calling that product. And then we're going to go and print off that product value. I'm using a little tab in there just to kind of make it spaced out very nicely. One thing to notice that's actually quite important, in this inner loop, the column loop, I'm not printing out any end lines, so it doesn't kick down to a next line. And that's why the entire column prints out on one row. But then after all 6 columns are done, I do need to get to the next row, and that's why this cout is here. Notice that it is outside of the column loop. The column loop's done, but it's still inside the row loop. So each time we finish off a row and have printed all 6 column numbers, then we'll do a little end line to kick it down to the next line so that the next time a row prints out, it's on the next line. So that works pretty well, but it doesn't have any column headings or row headings. The next section of code is pretty much the same thing, but it just looks a lot nicer. So this is the code. It's a little bit longer looking because it's going to do a little bit more stuff. And let's look at the output and then see what each little section does kind of bit by bit. So the output on the screen looks like this. It's kind of nicer. It's got the column headings up top, all 6 of them, and then the row headings off to the left, 1, 2, and 3. And then you can kind of do your classic multiplication table lookup to see any particular value. So working through it, the very first thing is just a little tab over, just to make some little space. That way the first column heading is kicked over by 1. This for loop here prints off the first 6 columns. And you might kind of wonder, well, why don't I just print off those things just in a simple cout? The advantage of this is if all of a sudden I wanted to do a multiplication table that was 7 wide or 5 wide, all I have to do is change that number. Right now it says less than or equal to 6. A simple change of that, we can change the size of this multiplication table. So that's going to print off those column values and a little tab between each one. And then the cout at the end of the loop, it's after the loop, is going to kick down the display. So we're ready to print off that little line of equal signs. And that's this loop here. This is going to print off kind of 6 batches of equal signs. That should be enough to work my way across the page. And then once I'm done that, I will have to kick down to a new line. So that's what this cout is right here. Okay, just kind of moving that display up where we can see it. Here's the kind of the guts of the program where we print off each of the 3 rows. So this is the row loop. There are 3 times we're going to have to go through this loop, and everything that's highlighted in yellow there will happen 3 times. It's within that code block. So what are we going to do? Well, first of all, we're going to print off the row name and then a little vertical line. Okay, so that will do that first little section there. And then we're going to go and print off the 6 column values for the multiplication. So this will calculate the product and print out those values. Notice there's no end line in there because we want to keep printing everything on the same line. And then after the 6 columns have been printed, done each one, which is this section here, right, where we calculate the value for the product and then print it out. After that's happened 6 times, then we've got that end line that's going to get printed to kick us down to the next line. And then it will do that. And you can easily change it to, instead of being just 3 rows deep, you can make it 30 rows deep. That's the nice thing about doing the loops, is that you can easily change your code later. Last little part of the sample program is this loop here, which at first glance looks a little intense, but it's actually, if we break it down bit by bit, it's not too bad. It's actually going to test numbers to see if they're prime. And we'll just kind of take a look at each section of the code here and see what it does. This first section is just going to ask the user, hey, give me a number, give me an integer, and I'll tell you if it's prime or not. And then we'll declare that variable number to test. So whatever they give us, that'll get stored in number to test. And then we'll just ask for a cin, so they have an actual chance to input it into the computer. And if you think about how you test for prime numbers, like if somebody says to you, hey, the number 33, is it prime? The usual way that you kind of think about it is you say, well, I'm going to assume that it is prime until I can find some factor that goes into it nicely. And then I'll say, oh, no, it's not. And that's what this next section of code starts to do. The first thing we're going to do is declare a brand new variable type to you. It's called the Boolean type. And Boolean is named after a mathematician who did a whole bunch of math all about trues and falses. And those are the only 2 values that these variables can have. They can't be 5 or 3.2. They can only be one of 2 things, true or false. So I'm declaring this little question in my mind. The number is prime as a Boolean, and that variable, the number is prime, can only take on 2 possible values, true or false. And right off the start, I'm going to say I think their number is prime. So the number is prime equals true says, no, let's assume it's true until we can find some sort of factor that might go in. Then we'll go, no, it's not. And that's the test right here inside this for loop. So if somebody says to you, hey, 33, is it prime? Well, you start running through numbers to see if anything goes in. Does 2 go in? No, it doesn't. Does 3 go in? Oh, yeah, it does. So it's not prime. Now, we know you don't have to keep testing, but there's no harm in continuing to test and saying, does 4 go in? Does 5 go in? Does 6 go in? As long as we know that this thing's definitely not prime, because we saw 3 go into it for sure, and so will 11. But if a number like 37 comes up and people ask you, well, is that prime? You can sit there and go, does 2 go in? No. Does 3 go in? Not nicely. Does 4 go in? Not nicely. Does 5 go in? And if you can't find anything that goes into it until you work all the way up to 1 below the number, then that thing definitely is truly prime. And so this for loop's going to do that. We're going to check for possible factors, starting at 2, working our way up until just before the number. So as we look through it here, the section of code that's going to actually do that testing is within the for loop. The for loop itself will start testing possible factors at 2, and then you can see the middle part of the for loop there. If that possible factor is less than the number to test, we're going to keep looping. So we're going to check, like, does 3 go into 37? Does 4 go into 37? Does 5 go in? And each time we test, we'll go to the next possible factor just by incrementing. That's what the possible factor plus plus does. Within the loop itself, that's where we're actually going to do the testing, and you can see it here in the code where it says if the number to test, and then there's that % sign, possible factor equals 0. If that's true, then we're going to set that the number is prime to false. So let's kind of think about that if. That's a division where we're going to look at remainders. Okay, it's that modular or modulo arithmetic. So we're going to take the number that they've given us, number to test. We're going to try dividing by the possible factor and see what the remainder is. If things go in perfectly, like when you take 36 and try to divide it by 4 and you go, oh yeah, it has remainder 0, that's what we're going to see here. So if the number to test divided by the possible factor has 0 remainder, then we need to just note that and say, this number is not prime. So when we ask the question, is the number prime? We have to say, no, it's false. And so that will go through, and if it ever finds any factors that go in, it will reassign that Boolean variable to false. It will never reset it to true. So you don't have to worry about it finding one number that goes in, but then the next number it tries after that doesn't go into the number to test, and then resetting it to true. It won't do that. It'll just switch it to false and then never go back. And then the very last little bit of the code just prints off the correct display. So again, it's this if part right here where we actually go and see whether or not this number is prime. We're going to check every single possible factor, starting at 2, working our way up to just 1 below the number. You know, technically speaking, you really only have to go up to the square root of the number, so this is a little bit overkill and the program might run a little bit slow. But for now, if it makes sense to do it this way, there's really no harm in this. We're not really worried about efficient computer code right now. And then, yeah, this last part here will display whether it's prime or not. The cool thing about these Boolean variables is they are perfect little conditions for ifs. So inside my red brackets for my if, I don't have to do any less thans or equal tos. I can just say if the number is prime, and it's got this nice flow to it. It almost just sounds like good grammar from English. So if the number is prime, then print off, yeah, the number that you gave me is prime. Otherwise, print off the number you gave me is not prime. So it's kind of neat using those Boolean variables, especially in those ifs when we're doing our tests. And that's the last little part of the program for the sample program for today. And so these were 4 loops where you know how many times you're going to do the loop at the beginning of the actual loop.